the nature of the root of quadratic equation. We know our root, right? When you solve quadratic equation, either using factorization, computing of square, or the quadratic formula, we get two equations. That we get two answers. That answer that we get, that's the root. So we are going to describe its nature. How does its nature look like? So the nature of this root is determined by using the discriminant. That's d equals b squared minus 4ac. When we are proving the quadratic formula, we saw b squared minus 4ac, right? Now, 1, we have real and distinct or different roots. If d is greater than 0, so if we substitute and we get the answer is greater than 0, then it's real and distinct. But here, what's the implication? When we solve the quadratic equation, we get our s value was 3 and 6. It means that the answers are different. So it means that it's real and distinct. That's the nature of that root. Okay. We have the other one. We have real and equal root. If d is equals to 0, so if you substitute and you solve for it and you get the answer is 0, it means that it's real and equal root. But what does it mean? When we solve a quadratic equation and we get that the answer have the same answer, for instance, our s1 is 3, s2 is 3, it means that it's real and equal root. That's the nature of that root. And last, imaginary root or complex root, if d is less than 0. So this one is the imaginary root. So if you solve it and you are getting your answer in the complex numbers, then it means that it's in an imaginary root. That's the I and co, right? So let's see some GeoGebra drawing on this. If d is less than 0, that's the complex, that's the imaginary. It may have no real root, that's the imaginary. So it's that it is on the complex word. So this one is not touching the s axis. That's why we say it's imaginary. It's on the complex, so it's difficult to get the s value. So it's not touching the s axis. Now, this one, if d is equal to 0, that's real and equal root. It means I have one real root. So this one is touching one of the s axis. So it means that the s value s1 and s2, the answers are the same. So it touches one of the s axis, only one. And this one is real and distinct or different root if d is greater than 0. So it's cutting two of the s axis. That's why we say it's two distinct real root. That's a real and distinct root. So if you do algebra, this is how the graph look like. So let's solve some examples, simple example under the discriminant. So they can ask you to determine the nature of this quadratic equation or find the discriminant of this quadratic equation. It's easy. You just code the discriminant formula, then you substitute it, then you find it. So determine the nature of the root of this. 2x squared minus 5x plus 3 equals 0. So what should we do? So this one is a quadratic. So our A will be what? So solution. These are quadratic. So let's compare. Therefore, our A is 2, our B is -5, our C is 3. Then what's our discriminant? This is our discriminant. That's the D equals b squared minus 4ac. So since we know our A, we know our C, we know our B, we just do the substitution. As easy as that. So let's do our substitution. So our D, this is our substitution. Therefore, our D is what? Is 1. Since D is greater than 1, then what's the answer? The roots are real and distinct roots, because if d is greater than 0, then it's real and distinct root. So this one is real and distinct. So if you solve this quadratic, you say you get two different answers. That's why you can try it and compare. So it's real and distinct root. This is how you go about it. As easy as that. Let's do another example here. 9x squared plus 6x plus 1. Solution. Our A is 9, our B is 6, our C is 1, so as we are comparing. So let's substitute. Our B is 6 and our A is 9. If you substitute this one, therefore our D is 0. If I did zero, what's it? What's its nature? Yes, equal roots. So since D is zero, therefore our roots are real and equal. Real and equal. So subscribe to Senior Police, my YouTube channel for more videos. Bye bye.